what happens when one of the forces is at an angle. So we have this box, its weight is 100 newtons. We apply a force of 100 newtons at an angle of 60 degrees, and we have friction for 20 newtons, and we're looking for the acceleration and the normal force. We always start by doing the free body diagram. This is my point mass. I have the force due to gravity, which is the weight. It is 100 newtons. I have the applied force F, which is 100 newtons at an angle of 60 degrees with the horizontal. I have friction, and I have some normal force which I'm looking for. The normal force will be less. The first thing the College Board wants is this free body diagram. But now we cannot work with that. We need to resolve the force F into components, horizontal and vertical components. And to do so, let's talk about the force separately. So we have this force, which is 100 newtons at an angle of 60 degrees. To find the horizontal and the vertical components, it's like finding Fx, the horizontal, Fy, the vertical. It's like finding the coordinates in geometry, algebra. To do so, let's remember that this is a right triangle. So if I redo this triangle, not a good one. So the hypotenuse is the F, which is 100. I do know the angle of 60. And this is, the one leg is the horizontal component, and this equals to that. So this is the y component. What I know is that the cosine of the angle is adjacent over hypotenuse. So the adjacent is Fx over hypotenuse, which is F. Solving for Fx, I have that Fx equals F times cosine theta. In the same way, if I use the sine of the angle, is opposite over hypotenuse, so the opposite is the Fy, and I'm finding that Fy will be F sine theta. The next question is, does the horizontal component always get the cosine? Well, if we know the angle with the horizontal, the x-axis, then the Fx gets the cosine and the Fy gets the sine. If instead I was given the angle with the y-axis, then the Fy would get the cosine and the Fx would get the sine. So let's move on. So we do know how to find it. The next step is do one more free body diagram. We don't put everything on the same free body diagram. We keep this as it is. This is what they wanted to see in the College Board. The next is for you, so you do the rest, so you solve the problem. So the free body diagram we have now is, we do have the force due to gravity, Fg. We have friction. We have normal force. And we don't have the force F anymore. We have the horizontal component Fx and the vertical component Fy. In the College Board, in case you need to do a free body diagram where you have two forces on the same axis, they have to be able to see that both forces start from the point mass. Okay, you have to make sure they can see it, and of course at the same time coincide with the axis. So what I found is that the Fx equals F cosine 60, which is 100 times the cosine of 60. That means that the Fx should be 15 newtons. Right. Now the Fy is F sine theta, which will be 86.67 something newtons. We do know this. And then, so we do the free body diagram. If we have a force, we split it. We resolve it by, like, in a graphical way and mathematical way. We do both. And then we go to what option we have. So we're looking for the acceleration apparently in the x-axis, because we may pull it like that, but the object moves on the x-axis, right? It doesn't fly, no. So again, we have the option 2. That means that the sum of forces on the x-axis should be mass times acceleration, while the sum of forces on the y-axis should be 0. Going to the x-axis, I have 3 forces. I have this, and I will consider this direction to be positive, this direction to be positive, and I have the friction, which is negative. So I have that Fx minus friction equals mass times acceleration. Fx 50 minus friction 20 equals mass. Do I know the mass? Yes, I do know the mass. I know the weight, the force due to gravity, and I know that the force due to gravity equals mass times g. So if this is 100 and consider the g to be 10, I will find that the mass will be 10 kilograms. So going back here, this is 10 acceleration times the acceleration, so 30 equals 10 times the acceleration, meaning that the acceleration will be 3 meters per second squared. Going now to the forces on the y-axis. What are the forces on the y-axis? We have, these are 3. We have the vertical component positive, up, the normal force positive, the force due to gravity negative. So Fy plus Fn minus Fg equals 0. The Fy is 86.6 plus the normal force minus 100 equals 0. So we can find that the normal force in this case will be 100 minus 86.6, which means that the normal force will be 13.3. Is it correct? 4. Let's have it 4. 13.4. We see that the normal force is not equal to the force of gravity. The only way normal force equals the force due to gravity if there are no other forces on the y-axis. If there are, normal force is different.